we have to find the limit as x approaches infinity of x to power 1 over x. So first, like always, we will substitute x's by, in this case, positive infinity. Let me put this in brackets. We will have infinity to power 1 over infinity. 1 over infinity, this is going to 0. So we have infinity to power 0. We got indeterminate form. So now we have to convert this form to 0 over 0, or positive infinity or negative infinity to positive or negative infinity, to use L'Hopital's rule. So first, let f of x equal x to power 1 over x. Now we will take logarithm of both sides. Natural log of f of x is equal natural log of x to power 1 over x. This is equal, from law of log we can take down this power and we have 1 over x times natural log of x. Now we will find the limit as x approaches positive infinity of natural log of f of x. This is equal, we copy limit as x approaches infinity, and we have 1 over x times natural log of x. Limit as x approaches infinity of, we have 1 over x, so we can put 1 times natural log of x is natural log of x, we have in numerator, and in denominator we have x. So now let's check what we have when we substitute x's by infinity. We will have natural log of infinity is infinity, and in the denominator we have infinity. When we have infinity over infinity, we can use L'Hopital's rule to find the limit. So now we have to calculate the derivative of function which is in numerator and derivative of function which is in denominator. So this is equal, we have limit as x approaches infinity of derivative of natural log of x is 1 over x, and derivative of x is 1. So this is equal limit as x approaches infinity of 1 over x, because when we divide 1 over x by 1 is 1 over x. We have limit as x approaches infinity of 1 over x. Denominator is going to infinity, to very large number. 1 divided by very large number is equal 0, is going to 0. We find the limit as x approaches positive infinity of natural log of f of x. We have to find the limit as x approaches infinity of x to power 1 over x. This is equal limit as x approaches infinity of f of x. Now we will use formula. When we have f of x, we can rewrite that this is equal e to power natural log of f of x. So we will have limit as x approaches infinity of e to power natural log of f of x. This is equal, now from properties of limit we have e to power limit as x approaches infinity of natural log of f of x. So this is equal, we just found this limit So we have e to power 0. This is equal 1. This is my solution.